So here we're going to look at the most important measure of spread that we will be using, called the standard deviation. So on the way to finding the standard deviation, you find something that's called the variance, okay, which is nothing more than the standard deviation squared. And the variance, the units on the variance are weird because it's like in square units of whatever you're measuring. But again, the variance is just something that's used because it has nice mathematical properties. So nice or we'll say convenient math properties. So that's one reason we use it. But really, the standard deviation is going to be the most important measure of spread we're going to be looking at. So let's look at an example in the next slide. Okay, so this example says Miss Fitterer measured the heights of 5 students in her stats course, and the following are their heights. So we're going to start this computation by listing the data values as we've done here on the left. We've already done the courtesy of finding you the mean. So I wrote down the mean next to every data value. And now we do the data value minus the mean to get, if you recall, it's called the deviation. Okay, so 65 minus 66.4 is negative 1.4. Okay, so I'll just put a subtraction symbol to indicate that's what we're doing. 68 minus 66.4 is 1.6. 60 minus 66.4 is negative 6.4. 72 minus 66.4 is 5.6. And then 67 minus 66.4 is 0.6. Now, we have a problem because we still have some that are negative. If we added them up, we would get 0, which we don't want to do. We want to get rid of the negatives. So we've learned that we can take the absolute value, and I mentioned that another way of doing that is to square. So let's square these values. So negative 1.4 squared gives you 1.96. 1.6 squared gives you 2.560. Negative 6.4 squared gives you 40.960. 5.6 squared is 31.360. Oops. And 0.6 squared is 0.360. Okay, so we've taken care of the fact that we had negative values, and now those distances are now all positive, but they're also squared, so we have to kind of undo the squaring later. But the first thing we do is we add the sum of this column. We find the sum of this column. So adding these numbers up gets you, and you can check, I believe, 77.2. Okay, so that's the sum of the squared deviations. And we divide by n minus 1, as we mentioned, so we pretty much find the average. The minus 1 is, for reasons, has something to do with what's called degrees of freedom, so we'll just ignore that for now. Okay, but if you do 77.2 and divide by n minus 1, remember n is 5 for us, so n minus 1 would be 4. You get 19.3. Okay, that is the variance. That's the variance. Now the problem with the variance is its units are now in square. I mean, these heights are all in inches. So if you follow the plot here, that 19.3 has units that are square inches, right? Because we found a distance between the mean height and the individual heights. That would be measured in inches, that distance. You square it, now it's in inches squared, and when you average that, you'll get inches squared. So that's the variance. We need to square root to get inches back, and also undo the fact that we squared those deviations. So the square root of 19.3 gives you about 4.393. okay? That is our standard deviation. So what does that mean? I'm going to write them here because they're a little bit small there. So that's our variance, and our standard deviation is 4.393. And again, the units on this is inches, the units on this is inches squared. So this means that students' heights in this class varies from the mean by an average of 4.393 inches. Okay, so just in general, what we're basically saying is that number, that standard deviation number, tells you, or it's a representative of how spread out the data is around the mean. Okay, so like if the standard deviation was like 20, that tells us something about how far away the values are from the mean. Okay, it means that there's a lot more spread around the mean than there is in this case. So the variance general formula, you'll see variance written with an S squared. The general formula looks like this. Okay, if you come across these symbols, this is what it means. So we summed, that's what this means. We summed all of our data values, or rather we summed the difference between the individual data values and the mean. We squared it, and then we divided that answer by n minus 1. And then the standard deviation, of course, would just be the square root of that expression that we see there. So that is the standard deviation. Now, most of the time, you're just going to let your calculator do it. And the big idea is you want to understand that the standard deviation is an average, is a measure of the average distance the data value is from the mean. And you should be able to answer some conceptual problems based on that, which we'll take a look at in the next video. Using screenshots, I've just sort of summarized how you can find the standard deviation. Okay, so and just basically how to find everything that you need to find in general if you're looking at one variable statistics. We've talked in prior videos about how to put data into lists, and I've just got the button pushes here that would get you to the one variable stats. And I just want to point out the standard deviation again. The standard deviation is that guy right here. Circle it, it'll get rid of it. That's your standard deviation. Okay. But doing this gets you everything else. I mean, that's mainly how we're going to find standard deviation. But this is also how we can find the mean, right? So we've talked about that. That's the mean. We know that this here represents the 5-number summary. Okay, so just by putting the data in a list and doing one variable stats, you sort of get everything you care about.